Hold your hands still.
So because free energy is a state function, there are ways to determine the delta G of a reaction given the delta G of a similar reaction. There are three relationships that we must keep in mind when doing this. So the first one, if we multiply a given reaction by a factor, we must multiply delta G by that same factor. So in this equation right here, carbon plus oxygen yields CO2. The delta G of the reaction is negative 394.4 kilojoules. Well, say we needed to multiply this reaction by 2. So we get 2 carbon plus 2 O2 yield 2 CO2. Then we multiply the delta G also by 2. So you need 2 times negative 394.4 kilojoules, and you get the answer for the delta G for the second reaction. Also, another way we can do it, say we need to flip this same equation. So we have carbon plus oxygen yields CO2. Again, the delta G is negative 394.4 kilojoules. Well, if we need to find CO2 yields carbon and oxygen, we simply switch the sign of delta G. So instead of it being negative 394.4 kilojoules, the delta G of the reaction is now positive 394.4 kilojoules. Lastly, this whenever you have, say, 2 or 3, maybe 4 reactions that sum to an overall reaction, we add the delta G's of these reactions to come up with the overall delta G. So, if you look at this, we have 3 CO2 plus 4 H2O yields C3H8 plus 5O2. 3 carbon plus 3 oxygen yield 3 CO2. 4 hydrogen plus 2 oxygen yield 4 H2O. So, we can see that we have 3 carbon on this side and 3 carbon on this side. So those cancel out. We also have 5 oxygen right here, 3 oxygen on this side in the reactants, 2 oxygens here. So these cancel out. We also have 4 O2 in the reactants here, and H2O, sorry, and 4 H2O in the products here. So these two cancel out. That gives us an overall equation. We have 3 carbon, 4 H2 in the reactants, and 1 C3H8 gas. So, since we crossed all those out, we have these 3 delta G's. These were given using these two relationships to determine the delta G of these 3 reactions. We simply add up these 3 delta G's to get our overall delta G for this reaction right there. Any questions? Yes, Emma?
All right, Dr. Blue, I'm still so confused. Why can we do this? I don't get it.
Okay, remember how I said that free energy is a state function? Well, a state function means that it doesn't matter how you got to the particular value, it just matters where you started and where you end. So, to put this in perspective, say you flew from New York to California. Doesn't matter if your flight stopped in Florida and then Montana on the way to California, it just matters that you started in New York, you ended in California, and that's kind of like here. We started at one value, got to the next one, and that's what a state function is. Does that make sense? Yes?
Why are we going to California?
Oh, you should maybe pay attention more.